Welcome to Software AG Government Solutions Complex IT Simplified webcast. Today's program, Devices Are Complicated, Your Strategy Shouldn't Be, will be presented by Adeel Chohan, Director of IoT Professional Services. Should you have any questions during today's program, please submit them into the question box located under the video screen that you're now viewing. Should we not have the chance to get to your question, it will be noted, and today's presenter will be back in touch with you as soon as possible. Here now to begin today's program is Adeel Chohan.
Thank you, Will. Hi, everyone. As Will mentioned, my name is Adeel Chohan. I'm the Director of IoT and Analytics at Software AG. I've been with Software AG for a little over 6 years, and I'm new to the government solutions space. But today, my topic is going to be about how to make IoT simple. We realize that when you go about doing your IoT search online, there's a lot of stuff that you see that is quite difficult to understand, quite complicated to navigate. So my focus of this presentation is trying to disseminate some of this information for you guys to help you make better decisions in picking your IoT strategy. So as we get started, I wanted to bring out the starting fact at you guys. Various consulting companies have done research on the success of IoT projects. Last year, Cisco did a research and they came out with a number as high as 70%. Which says that 70% of all IoT projects fail. Other companies have done researches that say 30% of all IoT projects don't even go past the POC stage. So what are some of the reasons that you can disseminate to understand what you need to do to be successful, right? But furthermore, we need to understand why is it important for you to even invest in having a holistic IoT strategy. This is important because emerging technologies are making a huge impact in your digital business transformation. CEOs and government entities have significant material impact on business in terms of the way that you can revolutionize and streamline business processes. 42% of businesses have deployed at least one of IoT use cases in production, and 80% of them have realized greater value than what they expected their IoT journey would bring them. And these are research that was done by Gartner last year. So it is very important that as we go through this exercise here, that we have a common methodology on ensuring how we can be successful across your IoT landscape. Now, we've talked a lot about facts and numbers, but I really want to get to the meat of the discussion, right? Which is, why do IoT projects actually fail? The part of the problem with IoT is around the rapidly evolving technology and standards. IoT, as you know, means a lot of things to a lot of different people, and oftentimes it can promote a lot of creative ideas, but it can also result in lack of collaboration between business groups because they can have various different ideas on how to implement that. So the top reasons that we have identified by executing on various POCs, have been around some of these things that you're seeing on the slide. One of them being expensive to maintain, right? Unclear success criteria and hard to keep track of requirements. Cybersecurity, which is a huge aspect around any IoT project. The quality of your IoT strategy is poor, meaning it's not well-rounded. It doesn't satisfy a lot of use cases. And then the biggest one is that IoT, as we previously mentioned, is a rapidly evolving technology standard. It has, things from a edge connectivity perspective all the way down to cybersecurity. So oftentimes when you get into these IoT projects, you lack expertise in the IoT domain. Oftentimes you try reinventing the wheel and start building things from scratch, which in turn makes these solutions more expensive. So what is the state of the IoT framework, right? I think we should probably start there, right? So today's state of the IoT framework, on the left side, as you can see, I'm giving an industrial 4.0 example here. There are quite a lot of initiatives that you might have, such as autonomous robots, IoT, industrial IoT of things, cybersecurity, augmented reality, AI, and big ML. And on the right-hand side, you've got protocols that these guys might want to use. So things like wireless LAN, you've got Profibus, you've got Modbus, you've got Ethernet, right? So how do we actually make these protocols and these disparate technologies talk to your initiatives on the left-hand side, right? And that's really where our platform from Software AG comes in. So who are we? We are Software AG, who have a digital business platform along with an IoT and analytics device management platform that allows you to execute on a myriad of use cases without having to apply a different strategy for other devices. So our core components of our platform are device management, data and analytics, integration and API, process and application, and solution accelerators. When we go into our customers and when we talk about our IoT strategy, what we want to make sure is that our customers have a strategy of not only connecting to devices that they're wanting to connect to today, but also have a strategy on implementing use cases of tomorrow. The way that we do that is with a very strong device connectivity layer. We want to make sure that our customers, when they connect to their devices, have a sophisticated manner of receiving data, as well as having some sort of feedback mechanism. If something goes wrong and they're not able to connect to their device, how can they troubleshoot that? Most often, when you start go about your IoT journey, you may start off with trying to build a solution yourself. However, with a platform-based approach, what you can do is you can use some of the built-in features of a platform to allow you to have a more flexible strategy. For instance, today's devices may call for using an open source protocol like MQTT. But if tomorrow you have a slightly different device that doesn't support MQTT, you may now start having multiple different systems that are required to be maintained separately. And this is why having a platform-based approach is quite useful, because you can have all those devices essentially integrate into a common data access layer. And within that data access layer, you can then start defining what you need to do. And this is very important from a security aspect as well, because you want to mandate how the connection goes in and out of your platform or your IoT strategy, for instance. So once we have devices connected, what we offer our customers is an ability to um, run analytics, and then also allow to build certain integrations that can execute on a myriad of use cases. So for instance, on a data and analytics layer perspective, we provide a streaming analytic capability, which allows you to build models that will allow you to execute on several use cases, such as condition-based monitoring, predictive maintenance, and other things such as firmware compliance. All of these things can be built in directly to the platform, where you can execute your strategy in a holistic manner. And once you've got your devices connected, you've got your data and analytics layer figured out, you can then start integrating this information with your backend and front end systems. Now, our platform does have the ability to do uh, front end visualizations as well. So this can be an end user based platform, but more often than not, you also want to reciprocate some of these insights back to your order management systems, or back to your SAP systems. So once your devices are connected and you realize that there is a potential fault in your device, maybe your device is out of firmware compliance, perhaps it has detected a fault and it's going to cause a slowdown in your production process. All those alerts and decisions can be automated through our integration layer that can go back and create automate service tickets and other types of automation that can return yield on the ROI. Furthermore, we do have a concept of solution accelerators that we offer to our customers. So we encourage our customers to use the capabilities that are offered within the platform, which means that if you are using a proprietary protocol or a common access protocol like Modbus, OPC-UA, CAN bus, these are typical industrial IoT protocols, you can use our solution accelerators to essentially accelerate the way that you adopt and use these protocols. So you don't have to start from scratch. We can provide you certain templates and certain frameworks that you can use as part of your IoT strategy for things such as, let's say, predictive maintenance, or things such as connecting to a BLE gateway, or having a solution accelerator for asset management. All those things have a framework and a template that we offer in our platform that can be used as a way for an accelerated adoption to your IoT use case. And oftentimes that is the inception point of how most clients leverage our platform. They will use our solution accelerators to execute on a smaller use case and tweak the use case to then achieve greater success into the project. And some of these things that I'm talking about, end to end, connecting a device and doing analytics and visualization to integration, can take days and weeks as opposed to months and years, right? The effort of doing all these things within our platform is allows you to be very flexible in terms of your IoT strategy. Now, I did talk a little bit about device connectivity earlier, but I wanted to continue on stressing how important this is for a connected device strategy. Having a foundation for a strongly available device management layer is important to execute on a myriad of use cases. So we continue to add pre-integrated devices into our gateways, along with out of the box support for many protocols. However, our developers can also use our device SDK to integrate devices that are potentially complicated or complex in nature. So the example that I like to give is, we've got a few customers in the medical space that are using our SDK to integrate very deeply with medical devices and doing firmware management to ensure that they're being compliant. Any new packages that may be pushed, or any new functionality that needs to be pushed, can be automated in a fashion through our platform, because that device management SDK knows how to interact with that particular device. But not all devices, are open devices where you can install pieces of code and execute a custom strategy. If your device exposes, for instance, a REST API or an MQTT, or is using NB-IoT or LoRa or any of those protocols, we can also consume those natively within the platform. And all you have to do is map it into a common data model. And this common data model is what makes this platform shine its light. Because once you have that common metadata in place, then you can have a strategy that you can apply across thousands of assets simultaneously. Meaning, if I have to do a firmware update on 10,000 devices and I want to do it incrementally, because all of these at that point have translated into a common protocol or a common data model, then I can essentially use this strategy across all the devices that follow a certain parameter or a certain type. What's also important as part of a device management strategy is being able to do remote troubleshooting. Some of our customers are using our device management layer to do things like remote restart on devices, or applying configuration changes, or requesting log files so they can provide better support to their customers to allow for sophisticated analysis of why a particular machinery is not working properly. And this happens to be another use case that is very common. Is most people, when they think about their device management or device connectivity use case, they typically stop just at the data transport layer. However, the chances are that when you deploy in production, you need to do a lot more than just your operational data. You need to understand the overall health of your device. You need to understand what you need to do if you haven't heard back from the device. And furthermore, you need to apply this strategy across many different types of devices, across many different types of use cases. Maintaining that by doing a custom build solution can oftentimes get very expensive and can often have security implications. So this brings me to the next topic of what are the connectivity demands of today's IoT architecture. The first thing that I've always that I've been stressing since the beginning is around the security aspect. Having a distributed architecture is quite important, and Cumulosity is a distributed architecture, meaning it is available within a cloud system. It is available within an edge system, and it can also run on a small Linux-based device. So it allows you to be very flexible in your strategy. So what is the value of such architecture? Well, the first thing is security. Typically when we see IoT applications in industries like oil and gas, utilities, manufacturing, or government institutions, one of the big things that they ask us is, how can you create my environment more secure? Some of these things may include things like stripping of sensitive information, such as, equipment connected to nuclear plants or where sensitive or PII data may be processed. So here what we can do is we can use capability on the edge to strip out information that is confidential or information that doesn't need to be sent to the edge. And for this system, it is important on having a solution that can work independently across various different architectures and in an isolated non-com environment to have things like multi-tenancy, encrypted communication, and all that kind of jazz. So once you have that security layer defined, then you can also benefit from things like local data processing. You can also do data volume reduction, and you are basically doing overall cost reduction on the way that you're maintaining your ecosystem. And we have some use cases where our customers are connecting to devices that are sending data in milliseconds, and we have to score that information in real time to understand if that data is meaningful or not. Some of these may be things from an oil and gas perspective that may show that there's a fault within one of the plants. And we have to, using the streaming rules that are within the platform, have to determine if this information needs to be sent to the next node or next level or not. Some of these may be cloud systems. So having a good consolidated edge strategy allows you to essentially not only have a security layer associated, but also benefit from things like real-time performance, low latency, and low response times. And once you have this layer defined, you're essentially creating a development pipeline or a operational layer that can be reused over time. We have um, cases where these environments are developed outside of their environments, meaning in a lab and in a very controlled space. And then once you know that this is how those environments are going to physical environments are going to act like, you take those configurations and you deploy them back in those respective environments, allowing a simplified development and reusability and interoperability between all the connected systems. Now, you may be asking me, so how is all of this possible, and how can you make my life simple with with a tool like Cumulosity, for instance? So it turns out that our platform has various different capabilities from a deployment perspective, and this is quite important from an IoT strategy because no size fits all for IoT. You may be in an environment where you don't have access to good network connections and you must process data locally, or you may be in an environment where you need to provide or supply your own hardware, and for that you need to have a appropriate services running so that you can process the information in a very secure and seamless manner. um, our distributed architecture strategy is based on a Lambda approach, and we have the ability to essentially, as mentioned before, to deploy on premise or in the cloud, um, on a thick edge server, and think of it like an industrial factory where you are processing large amounts of data locally, or on a thin edge, meaning a sensor or a Raspberry Pi like device, or even furthermore down on a device such as a sensor or node. And across these disparate edge, we are using the same SDK as I mentioned before. So everything is cross compatible across these various different architectural nodes, and you can identify and have a strategy around how you want to communicate some of this information back to all of these other systems. So in a typical deployment, you may have a cloud system sitting behind a government enclave. You may have a local site that is processing some of this information, and then you may have various different edge devices or gateway devices that are collecting data from, let's say, proximity devices for COVID-19 tracking, right? So we can essentially have a very consolidated strategy on how can I collect data from these sensors? How can I store it in a manner where if my infrastructure goes down, I'm not going to lose my data. And once I have stored that data and I have identified, let's say, a positive COVID-19 encounter, a rolling 15-minute, 24-hour CDC compliance period, how can I reciprocate and take this information and inform my cloud enclave where maybe I have in a separate system a electronic health record that can marry information and do actual contact tracing. So those types of things, we've done in the past in various ways, shapes, and form. And truly, one of the differentiators for this other one government entity that we were working for was the ability to be device agnostic. So if tomorrow they had a different emerging need for a different type of device or a different type of use case, they won't have to change the strategy or any of their security policies. They can continue on using the same exact platform and then apply a different device to it and build the use cases on top of those devices. And furthermore, the other important aspect in figuring out your device management strategy is your stakeholders, right? What are they going to be expecting, and who are the main interaction points of this data? Oftentimes, when we get into these IoT use cases, we get really excited about the technology that we're working with. But really, at the end of the day, having a very well-defined use case and going back and identifying what are some of the business use cases and business rules around the process that you're trying to orchestrate is very, very important. More often than not, these things do require enterprise integration, things like having a security evaluation of everything, collaboration from various different folks, and understanding how your strategy may evolve in the next few years. So one advice that I would give everybody is to be successful in a connected device strategy. You have to think big, but you have to start small, and you have to move fast. So try not to chew on 10, 15 different use cases at the same time. It's often better to start small, prove a small use case, and IoT needs to be a tactical approach to your project. And there must be IT/OT alignment in order for you to find success. And really, having a connected strategy with a well-defined use case is what's going to get you across the finish line. So a couple of things to recap. How do we overcome challenges? Well, the first thing is, you must embrace the failure. Things may not work the first time that you that you apply your IoT strategy to. Standardization will ease the pain for scaling. So as you scale across your enterprise for IoT devices, you have to standardize your processes, your documentation, and you have to align with the enterprise-wide digital transformation initiative with your IoT strategy. And all of these have to obviously, come from within, meaning you have to start small and improve value before you move on to investing thousands of dollars into an initiative and scratching it up later. And then last but not least, you need to understand that processes can change and it's okay. And transformation doesn't happen overnight. To connect to various different types of devices, having a consolidated IoT device management strategy is very important, but it's also important not to get lost in the various different buzzwords that you see online, right? So don't get lost in the fog, the cloud, the edge. The first step is defining a good business use case and picking the right vendor and making sure that if there is additional help that's necessary for you to succeed, that you're being proactive and reaching out to those stakeholders and counterparts. So if you guys like what I presented, we do have a trial available on our Cumulosity website at our government solutions page. You can go on softwareag.com/IoT and have a free trial of our solution. This is where you can connect your phone, your Raspberry Pi, your small devices, and do everything that I just talked about today. Furthermore, if you do contact us, then we can get in touch with you if you have various other use cases in mind that you guys want to discuss. At this point, I'd like to pass it back to Will for any questions.
Perfect, Adeel. Thanks. So I do have a few, so let me get into them with you. The first is you mentioned security is very important. What are some controls that Cumulosity addresses that allows IoT devices to securely communicate over the network?
Yeah, so I think it all goes back down to having a consolidated IoT device management strategy. So part of our device management layer includes things like two-way SSL, certificate-based authentication, unique username and passwords across the devices. So if one device gets compromised, you're not compromising the entire network. Really, I think at the end of the day, it's learning more about how you can work with the device vendor to make your strategy more secure. Our SDK will allow you to have certain principles in place that depending on your security controls will allow you to meet those. And by default, all communication in our platform is done over TLS. So your communications, internal and external, are fully secure. We well, what I would say is something that I've seen from a security aspect that is very beneficial is the ability to implement your own custom policies. Because more often than not, every single organization that you work with, they're going to have their own abbreviated security control sets, and they're going to ask you, well, I want FIPS blah 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 compliance, and I want to be able to do two-way SSL, and I need to do things like if I get 3 incorrect logins, I want to block that user profile. We can do all that stuff even on that device layer, because for us, a device is just technically a user to the platform, and that user can get compromised.
Very good. The next one I have for you. How do you address network issues in complex environments such as a factory floor where Wi Fi is poor and there is little to no Ethernet connectivity?
Yeah, so that's a good question. I think part of it also depends on the environment that you're running in. So we deploy in very complicated environments such as a shipboard environment where you're gonna basically have no connectivity for extended periods of time, up to 45 days sometimes. And it's important for the IoT solution to be self-contained, meaning in case of a network failure, you are still able to connect to your devices and you're still able to process this information. Oftentimes, when we do interact or when we do set up the IoT infrastructure, we like to keep our network sort of isolated. In challenging environments where Wi-Fi and Ethernet is not available, we can rely on things like Sigfox, BLE. There are other wireless technologies that can be used, but it is sort of one of those things where you have a lot of options but depends specifically on the site that you're working with. Um, I have even seen things as far as having a private LTE network to have redundancy in case if there is lack of network connectivity.
Okay. The last question I had for you is as follows. In most IIoT use cases, analytics is the core and key to success. However, more often than not, process engineers and business line of staff are unable to work efficiently to create the desired models. Turnaround times are long, can be costly, and sometimes inaccurate. How can one overcome this gap?
Yeah, so I think it all goes down to having a consolidated strategy for analytics. And the biggest challenge to any data scientist or any data analyst is capture of data. And then on top of that, getting access to the tools to do analysis. So most and let's say use the example of a shipboard environment or a factory floor in this case. If you're trying to do things like predictive maintenance or OEE, more often than not, your stakeholders probably have the formulas that they need if they had the data sources. But the challenge is that they don't know how to capture that data. So using a platform like like Cumulosity for IoT device management, you can have a layer to access the data. And then on top of that, we provide you a lot of interesting tools to analyze it. One of them being an analytics builder, which is a self-service interface tool that allows you to graphically build these models. So, think of it like a drag and drop based canvas-based tool where you can apply statistical functions. You can, say, I want the vibration and I want the motor current, And if I see 2 spikes in those that have, a standard deviation greater than XYZ, then I know that this is indicative of my machine failing over, and therefore I must raise an alert. And you can even go as complex as, if this alert hasn't been acknowledged, then I want to escalate it. And if it doesn't get escalated, then I want to, if it still doesn't get acknowledged after the escalation, then I want to stop my machine. Those types of models can be graphically created within our platform.
Okay, very good. Thank you then for the answer to all of those questions. Before we end, we want to just take a moment to thank everybody for taking time from their schedules to join this program. We especially wish to draw your attention to the website softwareag.gov.com, and on the very bottom of that page, you will see our events and webinars section, so you can click on that to follow and register for future programs that we have scheduled. So with that, Adeel, thank you very much for your time and a very interesting presentation. Our program has now ended. Enjoy the rest of your day.
Thank you.